to work with some word problems. We're going to be solving these problems using systems of equations. You should have a notes handout that looks like this. We are going to look at examples 2, 3, and 4 together. We're going to skip example 1 for the time being. So if you will look at example 2 with me, we'll get started. You'll probably need to put your work on a separate sheet of paper. Go ahead and get out another sheet of paper to do your work on, please. The school that Lisa goes to is selling tickets to the annual talent show. On the first day of ticket sales, the school sold 4 senior citizen tickets and 5 student tickets for a total of $102. The school took in $126 on the second day by selling 7 senior citizen tickets and 5 student tickets. Write and solve a system of equations that models the price of a senior citizen ticket and a student ticket. Alright, so whenever we're solving a problem, we are going to have to start by defining our variables. There are a couple of things here in this situation that we don't know. You can use whatever variables you want. I'm going to use the variables c and s. I'm going to use the variables c and s for this problem. If you want to use x and y, that would be fine too. We don't know the price of a senior citizen ticket, and we do not know the price of a student ticket. We know how many student or senior tickets they sold and the total money collected, but we don't know the price of each ticket. So for me, C is going to be the price of a senior ticket. And S then is going to be the price of a student ticket. Like I said, you can use whatever variable you want. I just picked these two for this problem. Okay, so we know that the first day they sold 4 senior tickets. My highlighter ready here. They sold 4 senior citizen tickets and 5 student tickets. So with that information, we could create one of our equations. We also know that they made or brought in a total of $102 that day. So 4 senior tickets, and the price of a senior citizen ticket we don't know, that's C, so 4C, plus there were 5 student tickets that were sold, so 5S, for a total of $102. On the second day, we know that they brought in $126. They sold 7 senior citizen tickets and 5 student tickets. So 7 senior tickets, 7C, plus 5 student tickets, 5S, for a total of $126. Alright, so we have a system of equation here, which we can solve to figure out the price of 1 senior ticket and the price of 1 student ticket. At this point, you have a choice. You can use substitution, you could use elimination, and really you could use graphing if you wanted to, but it's probably not going to be your method of choice. For this particular problem, I feel that elimination would be the best choice. I'm going to start by multiplying the second equation by a -1, which will leave me with -7C minus 5S equals -126. So I'm looking at the first equation and the third equation. Go ahead and add these two equations together. 4C minus 7C is -3C. 5S minus 5S is going to eliminate, cancel out, equals, we have 102 minus 126. That is -24. Go ahead and divide both sides by -3. So C is 8. We're talking about the price, so it is $8. Make sure when you find an answer that it seems reasonable. If we had gotten -$8 here, obviously that wouldn't make sense in the context of this problem. So be sure that your answer does seem reasonable for the problem you have. So let's substitute 8 back into one of our equations. You could use this equation, or even this equation if you wanted to. It doesn't matter. Substitute back in and solve for s. I'm going to use the first equation. So 4 times 8 is 32. Subtract 32 from both sides. Divide by 5. S is 14. The student tickets cost $14 each. Alright, so we've answered, we've really solved, we figured out what we want to find, wanted to find. Now I would like for you to write a sentence answering the question. The question is asking you to solve associative equations that models the price of a senior citizen ticket and a student ticket. So in our sentence, we're going to identify the cost or the price of each. The price of a senior ticket is $8, and the price of a student ticket is $14. So once again, I want you to define your variables, which we did at the beginning. We're going to write our system of equation, and then we will solve. Let's go to example number 3. Number 3 says the admission fee at a small fair is $1.50 for children and $4 for adults. On a certain day, 2,200 people enter the fair and $5,050 is collected. How many children and how many adults attended? So there's a couple of things that we don't know, and usually if you're looking for your variables, you're looking to define your variables, I try to look at the last sentence. It usually gives you some clues as to what your unknowns are. And our situation is telling us to find how many children and how many adults attended. So obviously that's our unknown. That's what we don't know. So I'm going to use x and y this time. And like I said before, you can use whatever variables you want. Let's let x be the number of children that attended. And y is going to be the number of adults. We know that it's $1.50 for each child and $4 for each adult. And on that particular day, they collected $5,050. So $1.50 per child, $1.50x, plus $4 times the number of adults, 4y, for a total of $5,050. Something I want to point out, $1.50 is money, $4 is money, $5,050 is money. It wouldn't make sense to put the 2,200, that number, with or inside this equation. It's not dealing with money. Now we are going to use the 2,200, the total number of people that attended, to write our second equation. We know of the people that attended the fair, some were children, X number of children attended, plus some of them were adults, for a total of 2,200 people. Now we have a system of equation that we could solve by graphing, substitution, or using elimination. You get to pick the method. I am going to use substitution for this problem. I'm going to take the second equation and I'm going to solve for y. So then I've solved for y. Now I'm going to take 2,200 minus x and put that into the second equation, or excuse me, the first equation for y. Okay, so let's go ahead and solve this new equation. Start by taking 4 times 2200, it's 8800, minus 4x equals 5050. So $1.50 minus 4 is negative 2.5x plus 8800 equals 5050. Subtract 8800. So 5050 minus 8800 is negative 3750. $1,500. So I have 1,500 children that attended this day. That seems reasonable. We know that there was a total of 2,200 people, 1,500 of them being children. The number of adults, I'm going to put 1,500 right here into this equation for x and solve to figure out the number of adults. So 2,200 minus 1,500 is 700. 700 adults. Now that we've solved our system, let's go ahead and write a sentence to answer the question. The question was, how many children and how many adults attended? There were 700 adults and 1,500 children that attended. One more question to look at, and that's going to be example number 4. Number 4 says, a test has 28 questions worth 100 points total. The test consists of short answer questions and worth 3 points each, and multiple choice questions worth 4 points each. How many of each type of question were there? Okay, so there's 2 unknowns that we don't know about this problem. I'm going to use the variables x and y. I'm going to let x be the number of short answer questions. I'm going to use SA for short answer. And y is going to be the number of multiple choice, MC, multiple choice questions. We know on this test that there were 28 total questions, some of which were short answer and some were multiple choice. So some short answer plus some multiple choice for a total of 28 questions. We know that each question was worth different point values. So the short answer were worth 3 points. The multiple choice were worth 4 points apiece for a total of 100 points. So 3 points per short answer plus 4 points per multiple choice for a total of 100 points. You could use whichever method you want to solve this. I'm going to use elimination. I'll eliminate my x's, so I'll multiply the first equation by negative 3. So, 4. So you have y equals 16. Y is the number of multiple choice questions. Of the 28 questions, 16 were multiple choice. Let's find the number of short answer. Put 16 back in for y. There were 12 short answer questions. So let's answer our question. How many of each type of question were there? There were 12 short answer questions and 16 multiple choice questions. Sorry about that. There were 12 short answer questions and 16 multiple choice questions. All right, that's all the notes that I have for today. Just a reminder, when you're doing these problems, I need you to define the variables that you're going to use in your equations, write your system of equations, solve the system of equations, and then write a sentence with your answer. If your answer doesn't make sense, or even sense enough to write an equation, then go back and make sure that you did the work correctly. Chances are you made a mistake if your answer does not seem to make sense for the context of this problem. All right, for homework tonight, we are going to try some problems. I have 4 problems that I would like you to try. Problems 1 through 4, this is the handout that you're going to be getting, modeling systems of equations. This will be due on Friday. We will talk some more about these types of problems on Friday as well.